Getting a solid grasp of radio frequency fundamentals is the first major step towards mastering the airwaves. Whether you are studying for your license or looking to build your own transceivers, everything in amateur radio traces back to three core concepts: frequency, wavelength, and modulation. Here is a breakdown of how they work and interact. Frequency, the heartbeat of the signal. Frequency is simply how fast an electromagnetic wave oscillates or cycles in 1 second. It is measured in hertz. In amateur radio, we deal with high speeds, so you will mostly see kilohertz, that is thousands of cycles per second, megahertz, that is millions of cycles per second, and gigahertz, billions of cycles per second. HF or high frequency band is from 3 MHz to 30 MHz. These signals can bounce off the ionosphere, a layer of the atmosphere, allowing for global communication. VHF, UHF, very high frequency and ultra high frequency, 30 MHz to 3 GHz. These are mostly line of sight and are heavily used for local repeater traffic and satellite operations. Wavelength and frequency are two sides of the same coin. Because radio waves always travel at a speed of light, if a wave oscillates faster, that is higher frequency, the physical distance between each wave peak becomes shorter. Wavelength is measured in meters and is represented by the Greek letter lambda. You can quickly calculate the wavelength of a signal in free space using this standard formula. Lambda is equal to 300 by f, where f is the frequency in megahertz and 300 represents the speed of light in megameters per second. Wavelength dictates the physical size of your equipment, most notably your antennas. If you want to transmit at 3.5 MHz, the math tells us the wavelength is roughly 83.3 meters. This means to operate efficiently on 80-meter band, an antenna like a standard half-wave dipole needs to physically span about 40 meters end to end to resonate properly with that wave. Modulation, carrying the message. A raw, unvarying RF wave, a carrier, doesn't convey any information other than the fact that a transmitter is turned on. To send voice, data or Morse code, we have to alter or modulate that carrier wave. Continuous wave, CW, the simplest form. You turn the carrier wave on and off in patterns, that is Morse code. AM or amplitude modulation. The amplitude, that is height and power of the carrier wave, is varied in time with the audio signal. It is easy to implement but wastes a lot of power and bandwidth. Frequency modulation. The amplitude stays constant, but the frequency is shifted slightly back and forth in time with the audio. It provides incredibly clear audio but takes up a wide chunk of bandwidth, making it mostly suited for VHF and UHF. SSB or single sideband, the undisputed king of HF voice communication. Standard AM actually creates two mirrored sidebands of audio information alongside the carrier wave. SSB circuits strip away the carrier and one of the sidebands entirely before transmitting. This focuses all your amplifier's output power into a very narrow, efficient slice of the bandwidth, allowing signals to punch through noise over vast distances.